Effective discharge area and minimum outlet. The effective discharge area is a really important concept, but to understand it and its importance, we need to take a step back and ask, what is really happening at the outlet of your discharge bin? As material descends down a converging hopper, the sloping walls squeeze the moving material, and the moving material pushes back on the hopper walls. In the process of doing so, the material is compressed or consolidated into a rainbow of arches. Now, it may surprise you, but during discharge, the weakest arch in this rainbow is actually at the outlet. This is because the load from the material above is not coming straight down, but is being progressively transferred to the bin walls. Having said that, the arch above the outlet is also the arch that requires the least amount of strength to become stable. Why? Because it is crossing over the smallest span. This is why when a storage bin bridges, it typically bridges at the outlet over the feeder. And good bin design is about choosing geometry such that the force from gravity that is being applied on the arch at the outlet is enough to break the arch. Because when the lowest arch breaks, there is nothing to support the arch above it. And so it breaks, and so on, all the way up the bin. That is material flowing down your bin. So how do we make sure the bottom arch will reliably break during discharge? We make sure that the span of this arch is long enough that we know that gravity can break it. But what is the length of the span of the arch at the outlet? The obvious answer should be the diameter or the width of the bin discharge outlet. Seems pretty straightforward. But it turns out that the behavior of the feeder has a big effect on what the true span of the arch at the outlet really is. We know that conventional feeders have a propensity to withdraw material preferentially from one part of the discharge outlet. So what does it mean if the area that the feeder pulls from is smaller than the outlet? What is the span that gravity is acting on? Is it the full outlet or only over the area that material is actually flowing? It is the area that material is actually flowing, and we call this area the effective discharge area. Because from the perspective of gravity, that is the true outlet, or the effective outlet of the storage bin. If the effective outlet is not bigger than the bulk solid's bridging dimension and you have mass flow, the bin will be susceptible to chronic bridging. Or if the effective outlet is not bigger than the bulk solid's piping dimension and you have funnel flow, the bin will be susceptible to chronic rat holing. It's a tough situation because here you would have a storage bin with good geometry but still suffering from chronic plugging. Maybe life is unfair, but when it comes to material discharge, gravity is indifferent about the physical opening of your bin. What gravity cares about is the effective opening or the effective discharge area. Gravity cares about the real span that the arch at the outlet is subject to, because that is what it needs to break in order to keep your bin flowing. In summary, when the feeder constrains the flow of material from the outlet of your storage bin, you have a smaller effective discharge area, which means that the arch over the opening has a smaller span, and the shorter the span of the arch, the stronger the arch. And when the arch is strong enough that gravity can't break it, you have a bridged bin. This is just physics at work. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the KamengoU website and download our white paper.